we are going to move this term to the other side. This term has 1 in front, and I'm adding 1 plus 9/4, which is 13/4. So here's what we get. 13/4, the integral from e to 2 theta, sine 3 theta d theta, equals these two, e to 2 theta over 2 sine 3 theta minus 3/4 e to 2 theta cosine 3 theta plus a constant c. Why? Because there are no more integrals, right? So I have to have a constant. This is an indefinite integral. So then, in order to find the final answer, all I have to do is multiply everything, both sides, by 4/13. 4/13 times 13/4 is 1. So this is e to 2 theta sine 3 theta d theta equals 4/13 times 1/2. So this will be 2/13 e to 2 theta sine 3 theta. 3/4 times 4/13 is minus 3/13 e to 2 theta cosine 3 theta plus a constant c. And this is final. I wanted to show one more example here, which is a volume from chapter 6. And now we can work on it because we know integration by parts. And that's the last problem for this section. Okay, 67 on 491. 491. Okay, so y equals cosine pi x over 2. Y equals 0. X is between 0 and 1. And we are rotating. We're asked to find, use the method of cylindrical shells to find the volume generated by rotating the area about the y-axis. So as you remember from chapter 6, we have to draw, we have to find the area, we have to rotate it and find the volume. Okay. So first of all, this is 1, this is -1, and we have 0 to 1. Okay, so y equals 0, very clear. X equals 0, very clear. X equals 1, very clear. So these are very clear. And we are rotating about the y-axis. But let's find the area. So when x is 0, cosine is 1. When x is 1, cosine pi over 2 is 0. And we know how the graph looks like. So the area enclosed by all this is this area. We are rotating it with respect to the y-axis, they say. And as we know, if we use cylindrical shells and we rotate with respect to a vertical axis, we have to integrate with respect to x. If we are using the method of disks, we are integrating with respect to y. But since we are integrating using cylindrical shells, and we are integrating with respect to a vertical axis, we have to integrate with respect to x. So remember how we say it. Through the area for a particular or any instant x. So the volume is 2 pi, the integral obviously where the area is, 0 to 1, from radius, height, and of course dx. For this particular x, rotating, we always have to picture that piece for which we determine the radius and we have to determine the height. Good. So the radius is very clear. For this piece, the radius is x. Also very clear, the height is nothing else but the y value. What y value? Cosine pi x over 2. And that's where integration by parts comes into play. Okay, so let's see what we get. I'm going to write it one more time because I have the radius and the height in there. So from 0 to 1, from x cosine pi x divided by 2 dx. Okay, so one option would be to use a substitution and make it easier, or because we have the preliminaries from the previous videos in this section, I can already say the integral from 0 to 1, I change this into negative, I'm sorry, positive, not negative, it's cosine. So sine pi x over 2 over pi over 2 prime times x dx. Remember how I do this? When I differentiate this, I get cosine pi x over 2 times the inner function prime, which is pi over 2, which will simplify with pi over 2. Okay. So now it's ready for integration by parts. Again, by inspection, we determine that without writing too much. Okay. So we have 2 pi fg. So I'm going to flip this. 2 over pi sine pi x over 2 times x, okay, fg, from 0 to 1, minus, don't forget 2 pi, the integral from 0 to 1, I keep this as 2 over pi times sine pi x over 2 times g prime. It is 1. Yay! Nice. When I plug in 1, sine pi over 2 is 1. So 1 here. Sine pi over 2 is 1. So I have 4. When I plug in 0, it be all 0. This is 0. Sine 0 is 0. Times 0, so the whole thing collapses. Minus. I have 4 in front. The integral from 0 to 1 from sine pi x over 2 dx. So this is 4 minus 4. Now, which function prime is this? Well, it's negative cosine pi x over 2 over pi over 2 from 0 to 1. But when I plug in 1 in here, cosine pi over 2 is 0. Minus. So 4 minus 4. So when we plug in 1, we get 0. When we plug in 0, we get 1. But that is 2 over pi. So this is 4 minus 8 over pi. Thank you. I hope this is clear and it helps.